Now coming to this question number 26, the number of integers n greater than or equal to 10 such that product is a perfect square. Now to do this question, we can use the formula for NC10, that is n factorial upon 10 factorial and n minus 10 factorial into n plus 1 factorial upon 10 factorial into n plus 1 minus 10, that is n minus 9 factorial. Now please check that what are the numbers that are already making perfect square, like n factorial is already making a perfect square. Upon 10 factorial is also coming with perfect square. Okay. Now n minus 9 factorial will also come with perfect square if I multiply in the numerator by n minus 9. Okay, this n plus 1 factorial I have written as n plus 1 into n factorial, and this n factorial is multiplied with this and we get n factorial whole square. Please check this calculation. N minus 10 is one lesser number than n minus 9. So if I am writing n minus 10 factorial as n minus 9 factorial in the denominator, I have to multiply it by this. Now please see, all these numbers are perfect squares, whether they are in a numerator or in denominator. We just have to focus on the product of these two to become a perfect square. Why I am saying so? Because this has to be an integer. Nobody can say that why it will be an integer. It has to be an integer. So because already these are perfect squares, so if these are also perfect square, and because they will be integers, so they will be, if perfect square, they will be perfect square of an integer. So we just have to make sure that n minus 9 into n plus 1 is some k square, and for that we will multiply it. We will get n square minus 8n minus 9 is equal to k square. If we make this as a perfect square, it will be n minus 4 whole square plus 16 minus 19, I think it will be minus 25 here, is equal to k square. So what we are getting, we can write it in two ways: n minus 4 square plus k square. N minus 4 square is equal to k square plus 5 square, and all these are integers. N minus 4 is integer, k is integer, 5 is integer. So this k and 5 should be Pythagorean triplet, and if they are Pythagorean triplet with 5, I think k should be equal to 12 and n minus 4 should be equal to 13. So n will become 17. Or what you can do, you can write this as n minus 4 whole square minus k square is equal to 25, one very standard method. So we will be getting n minus 4 plus k into n minus 4 minus k as 25, and they will be 1 into 25, because if they are 5 and 5, then I think it is not possible, because then one of them k has to be 0. I think that is not possible. So here 1 and 25, so I will be taking n minus 4 plus k as 25 and n minus 4 minus k to be equal to 1. Adding them will give n minus 4 to be equal to 13, and that is what we got there also. So n is equal to 13. If you take minus 1 minus 25, then also you can check, but I don't think that it will be possible. Let me just think. Actually, this n minus 4 has to be greater than k. So they both will be positive, positive, yes. So n will be 17, sorry. N minus 4 will be 13 and n will be equal to 17. So what exactly they have asked? Number of integers. So I think answer is B, that is 1. And you can check for n is equal to 17. This expression will become 17 minus 19 is 17 minus 9 is 8, and 17 plus 1 is 18, which is square of 12, I think. 18 into 8 is 144, 12 square.